Your whole timeline is screaming the same thing this week. Prompt engineering is dead. The models are cooked. The new meta is loop engineering. So let's cut through the hype, because underneath the clickbait, there's a real idea, and it is backed by actual research. Here is the honest version. A perfect prompt gets you one good answer. A well-built loop lets a model check its own work, fix its mistakes, and grind until the result is actually right. As the frontier models got dramatically better at every single step, the bottleneck moved. It stopped being the prompt. It became the loop around the prompt. That is what people really mean by loop engineering. So what is a loop? Strip away the buzzwords, and an AI agent is just a wild loop. The model runs. It requests a tool call. The tool result returns to the context. The model runs again, and it keeps going until it stops asking for tools. That is the entire heartbeat of every agent you have ever used. And this is not new. It was described back in 2022 in the React paper. Reason, then act, then observe, then repeat. Everything since is just a refinement of that loop. Here is the cycle in plain terms. Observe. The model reads the current state and the last result. Act. It calls one tool. Check. Something looks at the result. Then it loops, with that result now part of the context. A prompt is one turn of the wheel. A loop is the wheel turning until the job is done. Now, does this actually work? Or is it just more timeline noise? This is the part the hype gets right, and the part almost nobody actually read. There are peer-reviewed papers on exactly this. The first is a 2025 paper called LLMLOOP from researchers at the University of Auckland and King's College London. They wrap a language model in 5 feedback loops. 1 fixes compilation errors. 2 cleans up issues from static analysis. 3 fixes failing tests. 4 improves the tests themselves using mutation analysis. Then it reruns and refines every pass. The result, on a standard coding benchmark, a one-shot model scored 76%. The same model, run inside the loop, scored 90%. Same model. The only thing that changed was the loop around it. The second is a paper called COMPILOT from researchers at New York University Abu Dhabi. They put an ordinary, off-the-shelf model in a closed loop with a compiler to optimize code. No fine-tuning. The model proposes an optimization. The compiler measures it, the feedback goes back, and it tries again. They hit an average speed-up of 2.6 times on a single run and 3.5 times across 5. That beats the state-of-the-art classical optimizer, and on some programs, over 100 times. Notice the shape is identical in both. The model proposes. A deterministic checker judges. The feedback goes back into the context. Repeat. The model is the same as everyone else's. The leverage is entirely in the loop. So if the loop is where the value is, how do you actually engineer one? 3 parts decide whether your loop is brilliant or a disaster. First, context management. Every turn, the model rereads the tool output and stuffs it back into the context window. A long loop blows right past that window. So you compress. You summarize old turns, keep the recent ones sharp, and any state that must survive goes into a file, not the chat history. Second, the termination condition. This is the most important thing in this whole video, and the part beginners always skip. Your loop needs to know when to stop. And there are 3 good reasons. Done. The success condition is met. Stuck. It is repeating itself and making no progress. Or out of budget. It hit a cap on iterations, tokens, or time. Always set a budget. A loop with no stop condition does not run forever in theory. It runs forever on your credit card. Third, and this is the big one, how do you know the job is actually done? A deterministic success condition can be checked automatically. Did the code compile? Did the test pass? Is the link clean? A clean yes or no. This is where loops are magic. The loop verifies itself, so you can walk away and trust it. That is exactly why the coding papers worked. A compiler does not have opinions. The hard case is a non-deterministic goal. Make the landing page look good. Write a warm email. There is no compiler for taste. So you either accept a run you cannot fully trust, or you put a judge back in the loop. A human reviewing, or a second model scoring the first against a rubric. So a deterministic loop with a clean automatable check is the one you can safely leave running alone. A non-deterministic loop needs a judge watching it. Knowing which one you're holding is most of the skill. So when should you reach for a loop? Anything with a checkable end state. Rename a symbol across a whole code base and confirm it still builds. Reformat 1,000 files. Migrate an auth module and run the tests. Build a payment retry flow that catches the error and tries again until it succeeds or gives up cleanly. The recipe is always the same. Give the agent a goal, give a checker, give a budget, and let it grind. And now, take that loop and simply never turn it off. That is the always-on agent everyone is excited about. A long-running loop pointed at a standing goal. It watches your inbox. It manages your calendar. It monitors a metric. And it acts through tools across the channels you already use. People give it cool names and act like it is a new kind of intelligence. It is not. It is the same while loop kept alive with good tools, real memory, and sane stock conditions. So here's the honest takeaway. Prompt engineering is not dead. The prompt is still the first turn of every loop. And no, that famous coding paper was not secretly written by the engineers behind your favorite assistant. It is academic research. You can read it yourself. But the core claim is real. In 2026, the leverage is in the loop. Learn the cycle, manage the context, and above all, nail the termination condition. That is loop engineering. The model is a commodity. The loop is the craft. If this made the hype make sense, subscribe. We break down one rail AI idea like this every week. Send it to the friend who keeps saying prompt engineering is dead. And tell me in the comments, what is the first boring task you would put inside a loop and walk away from? Thanks for watching.